Trigonometric substitutions. Here we're going to learn how to evaluate integrals involving expressions like the square root of a squared minus x squared, the square root of x squared plus a squared, or the square root of x squared minus a squared, where a is a positive constant. And the way we're going to do it is we're going to get rid of the radical by making a substitution for x that's going to be a trig function. So let's look at an example to start with. Let's evaluate the integral of 1 over x squared times the square root of 4 minus x squared. So looking at this, you can see that our integral has the square root of a constant squared minus x squared, where our constant is equal to 2. Now looking at this, underneath our radical, the values that x can take on are between negative a and positive a. If it's anything else, then I'll get a negative number under the radical and we can't use it. So we need to make a choice for our substitution of x so that it takes on every value between negative a, but not any other values. And the way we can do this is if we look at the function sine of theta, then on that function takes every value between minus 1 and 1 exactly once on the interval negative pi over 2 to pi over 2. So we're going to let x be equal to a, that constant, times sine of theta. Now, using this identity that 1 minus sine squared theta equals cosine squared theta, we end up with the square root of a squared minus x squared is equal to the square root of a squared minus, and we make our substitution of x equals a sine theta here. So we get the square root of a squared minus a sine theta squared. Now let's simplify this a little bit. This expression right here, if I multiply out the square here, I get the square root of a squared minus a squared sine squared theta. I can factor out an a squared, and now the 1 minus sine squared theta is equal to cosine squared theta. And now I just take the square root of this expression to get that's equal to the absolute value of a times cosine theta. Now let's remember, we said that theta was between minus pi over 2 and pi over 2. So that's my fourth and first quadrant. And we know that cosine in those quadrants is positive. So now we can just get rid of our absolute value signs and say that the square root of a squared minus x squared is equal to a cosine theta. Alright, so let's make our substitution. Here's our integral that we want to find. I'm going to let x be equal to a, which in this case is 2 sine theta, and that means that dx is going to be equal to 2 cosine theta d theta. We go ahead and make our substitutions. For dx, we substitute in the 2 cosine theta d theta. And then wherever there's an x, I'm going to put 2 sine theta. So this integral becomes 2 cosine theta d theta over 2 sine theta squared times the square root of 4 minus 2 sine theta squared. Now we go ahead and simplify this integral here. And the radical here, well, we saw that that's going to simplify down to 2 times cosine theta. And then I just distributed the exponent here because it's multiplication to get 4 sine squared theta. And now I have a 2 cosine theta in my numerator and a 2 cosine theta in my denominator, and they can cancel out to give me, now I want to find the integral of d theta over 4 sine squared theta. Alright, so how are we going to find that integral? Well, after you think for a little while, you think about, well, there's no cosines in there, so I can't really make a good u substitution. But how about if you rewrite the 1 over sine theta as cosecant theta? Then this integral here becomes 1/4 cosecant squared theta. Ah, and now I know that that is the antiderivative of negative cotangent theta. So we get 1/4 times negative cotangent theta plus c, which is minus 1/4 cotangent theta plus c. Great. But we have a problem. We started our integral in terms of x, and we have theta here. So what we need to do is put our answer back in terms of x. All right. Well, what are we going to do? We said that x was equal to 2 sine theta, and we want to look at cotangent theta. How am I going to find that? Well, I could solve this equation here for sine theta to get sine theta is equal to x over 2. And if you think about triangles, sine theta is opposite over hypotenuse. So I can draw what's called a reference triangle and put x is my opposite and 2 is my hypotenuse. And then using the Pythagorean theorem, I can get the length of the adjacent. So that means that cotangent of theta is going to be equal to, well, it's adjacent over opposite, so cotangent of theta is equal to the square root of 4 minus x squared all over x. So taking that from our reference triangle, we get that our integral, which we said was equal to negative 1/4 cotangent theta plus c, writing it in terms of x, gives us it's equal to negative 1/4 times the square root of 4 minus x squared all over x plus c.